All right. Hello, and welcome back to the computer memory series for coders. And so last time I left off, I was talking about pointers. Ooh, pointers. Everybody's so scared of pointers, right? So what I basically said was we had these slots in memory, which you're probably used to at this point, right? If I could draw straight, that'd be great, but if not, oh well. Anyway, we have these slots in memory. Still getting used to my pad here. And each slot has a number, right? That could be 1, that could be 2, that could be 3, that could be 4, that could be 5. We could have like a 6 down here, etc. Now, these numbers, I'm sure you're aware, could vary. So it doesn't have to be 1, 2, 3, 4, 5, 6. It could be 5,567, 5,568. But the point is that they're in a sequential order, right? And that's always going to be true. So we have this memory like this, and before I was talking about how you could store like the number 5 here, you could store the number 4 here in 3 if you wanted, you could put like 56 here in 4, and etc. So I'm going to go ahead and I'm going to draw out one more memory space here. Okay, let's call this memory space. So I'm going to draw out some more slots. So we're going to have slot 1, slot 2, slot 3, slot 4, slot 5. So, and then, tell you what though, I don't want to call them slot 1 to 6 because I already have slot 1 to 6. So I'm going to call this slot, I'll call this, just for the sake of not confusing you, I'm going to call this A, B, C, D, E, and F, right? So now, what can be stored in these slots, right? So we talked about this a little bit before. You can have integers in here, you can have floating point numbers, and a floating point number is basically just literally like 6.5, right? That's a floating point number right there. Or it could be like 6.15, 1, 3, whatever, it's a decimal number. So you could have floating point numbers inside memory. You can have whole numbers inside memory. You can have, basically everything can be represented that way because, as I said, yes, you can have strings, which is text in memory, but ultimately it's just a number in memory anyway. And ultimately, even floating point numbers are stored differently than this in memory as well. But that becomes quite complicated, so I'm not going to talk about that. But just know that you can store memory values in memory, right? Now, that doesn't mean that we're just randomly storing values in here for no apparent reason. These values all mean something, this could either be data used in a program, like when somebody is programming, they write, int x equals 6, right? Semicolon, of course, or maybe not if you're doing Python or the new ECMAScript 6 and stuff like that. So there, right? So we just put 6 inside of memory slot 5, right? By doing that. Now, so that should tell you something right there too. So what is X? So to the computer, X is actually memory is referencing memory slot 5. That's what to us it's a word, or it's a way for us to keep track of this particular memory slot. But to the computer, it's still memory slot 5. That's what this X is referencing, right? So always remember that. Remember, think how the computer thinks, and it will help you understand this stuff. So anyway, so my point is that before I get over here to this red side here, I'm going to talk about one more thing, which is going to require me to actually erase or tell you what, I'll just make another extra slot just because we're talking about memory here, which is, there's a lot of it anyway, so why not just make one more slot? Ah, that was terrible. I just switched from my drawing thing to my trackpad, and you can see what happens. So we have slot 7 here, which looks like crap, but just bear with me. So let's say that in slot 6 is the address slot 1, right? So inside slot 6, we have the address of slot 1. So you go to slot 6 and you say, oh, okay, well, there's a address in here to another memory location, and that location is up here in slot 1, right? Well, let's say we want to store the address of slot 6 somewhere, and we want to put that in 7, right? So now we have the address of slot 6 stored as information or data inside of slot 7. So this is where things, like when you're coding and when you're first learning like C programming and C++, this is where stuff can be really hard and confusing, because I mean you're seeing it in the code and it doesn't help because you can't really visualize it like this. But what this is here is this is a pointer to a pointer. So 7 is a pointer to a pointer. So I'm terrible at drawing these things probably on here, but like in C, this is how you write it. It's double star, and then whatever it is that it's called, right? So you go to 7 and you say, okay, well, 7 has the address location of another slot in memory in it, so 7's a pointer. And when you get to 6, you say, okay, well, 6 also has the address location of another spot in memory. So 6 is also a pointer. So that makes 7 a pointer to a pointer. 7 is a pointer to another pointer. And then when you go from when you go to 6 and you say, okay, well, where does 6 point to? Well, it points to slot 1, which takes us up here. Now, there's not another address in here. Okay, instead there's an actual value, which is 5, right? Because in my syntax that I'm using to teach this, I'm putting the pound sign or the number sign here in front of numbers which correspond to a memory address. And if it doesn't have a pound sign in front of it, it's actually a value. So this is the value 5. It's not the memory location 5. Whereas here in 6, we have the memory location 1, and here in 7, we have the memory location 6. So that makes 7 a pointer to a pointer, and then 6 is a pointer to an integer, which the location that 6 is pointing to is slot number 1. Okay, so when you're looking at C code and you see this, you see int star y. So this is a pointer to an integer. So in our example here, we use the integer 5, right? So what this means is that now you have to, so y is a variable because, or y is a, it corresponds to a spot in memory, just like anything else, right? And that's also what variables they correspond to. They correspond to a slot in memory, right? So y corresponds to a slot in memory, but this star here, it means that that the information stored into the slot in memory that y corresponds to is just the address of another slot in memory. So when you're programming, you're writing out this kind of stuff, right? And the computer is seeing that is this kind of stuff right here. So to the computer, perhaps y is 6 is representing whatever is stored in address slot number 6, and perhaps that points to address slot number 1. So the way we would do this now is let's say you wanted to assign something to y. Well, then you would do y equals, and then that's where you would either put an address or you would put another variable, and it would grab the address from that, right? So, and there's a whole syntax for that. But again, I don't want to focus too much on the syntax because that's not really the point of all these tutorials, because this should apply to every different programming language and all computers. So I don't want to focus too much on syntax, but just for instructional purposes real quick, I'll just write so you could say y equals the address, right? Now I'm going to butcher this like crazy, so I'm just going to pretend this is an ampersand because I'm pretty bad at drawing those, especially on this pad here. So y is the address of, let's say memory slot 1 is, I'm not going to use x. Let's just say it's a, right? So we have a variable called a, and a represents memory slot 1, right? So now we would put the address of a is y, right? And what we're saying here is we're saying that y now refers to, it now points to slot number 1, because the address of a is number 1 and y is a pointer variable. So, but again, don't get too bogged down on all the syntax. In fact, I'm going to get rid of this part because I don't want to confuse you, because the syntax can be kind of confusing and it's not really that necessary. The most important thing here is the concept, and I'm pretty sure you understand the concept now because I've been discussing it quite extensively, that the computer's working with these different memory slots, right? And this would be a pointer to a pointer. I mean, it's pretty simple. Basically all the computer does is it has either information, like numbers, basically data. They call it data, information, numbers, right? And it does work on those numbers and it moves them around. That's it. And now we're going to go to something else here on the right hand side, and I think you're going to appreciate this because it's going to make even more sense, especially if you're already coding. So let's say in slot, let's do this. Let's do this. I'm going to use both sides. So let's say you want to do addition, right? So the computer has to know how to even do that. Like it needs to know that you want to do addition, right? And what do you tell it? You can't talk to the computer, right? So what the computer does is it actually even has codes for that. So let's say this is totally made up by me. This is not the actual code as far as I know. That'd be crazy if it actually was, but I guarantee you it's not. You have to go look at the what they call the Intel manual to find this kind of stuff out, or the AMD or whatever processor you're working with, Qualcomm, that kind of thing. But so let's say instead of this, I tell you the add is 56, right? So when I tell you I want you to take the number 25 and I want you to 56 it with 5, you're gonna give me 30, right? Because for all intents and purposes in this lesson, 56 means add, right? 56 means plus. So I told you 56 means plus. So now when I tell you I want you to take 3 and I want you to 56 it with 4, you're going to give me 7, right? So this shows right here that all the operations, even like the mathematical operations and the different commands that the processor carries out, can be represented themselves as numbers, which in turn is data, just like we have up here, right? It's data. So that's what actually happens. So the code, when you're programming as a programmer, eventually becomes these things called opcodes. And for our lesson here, we're going to say that 56 is the opcode to add numbers together. Okay? And we're going to place that opcode inside of B, right? In this slot in memory. So you can clearly see here that we can store the instructions, which is the program itself, that the processor should follow in memory as well. So it's not just the data that we're using in our code or for our code, and like user input and stuff like that, which is also stored in memory, but the code itself, it ends up being assembled down to instructions that themselves are also stored in another spot in memory, which in this case I'm representing with A, B, C, D, E, F, right? So what happens is there's this thing in the processor, and it's called the IP. Not the IP address, it's different. It's not Internet Protocol. It's the instruction pointer. And the processor ultimately can only really execute one instruction at a time, and that's kind of a loaded answer because it could actually do more, but one core of one processor, like one unit of work in one process. What they do nowadays is they basically split these processors up into different cores, and then those cores have like virtual cores. So there's like a whole bunch of different units. There's a whole bunch of different basically copies of those registers that I talked about in the previous lessons. They're throwing numbers around, but for our demonstration purposes here, the processor, and the way it used to be as well, is the processor can only execute one operation at any point in time. Now it's really fast because like a 2 point something or 3 point something gigahertz processor is executing these things like billions of times in a second, but it still can only actually execute one at a time, right? So the instruction pointer has to point to one instruction at a time. So the instruction pointer, let's say this is our program over here, right? So we got 43, we got 56, we got like 49, you know. So 56 is add, 43 is subtract, I don't know, 49 is like multiply, let's just say, right? So we're giving these different things, like these numbers, a meaning here, or an operation, right? So what happens is in memory of the code, where the actual program is written to, this instruction pointer is going down these different commands, and the commands are actually a little bit bigger than this, because what they're going to do, let me go back here real quick to make this. I'm going to extend this out, and it's going to make a lot more sense. I'll extend out my A slot here just to show you. So I'm going to extend this way out like this, and I'll extend this one out here in case I need one more slot here, right? So we said the number 56 is equal to add, right? I'm going to cross it out here so I don't confuse you. So 56 equals adding. So the program is laid out with instructions set in memory. So once again, we could have like 25, 56, 5 in this slot of memory that's in slot A, right? So now when the instruction pointer IP gets to A, that's what it's going to do. The computer is going to take the number 25 and it's going to add it with number 5, and it's going to get 30, and then it's going to take that 30 and it's going to store it. Okay, that's what it's going to do. Now when it's done with that, it's going to go to the next instruction, which it would be B in this case, but I scratched it out, so I'm going to extend it out here, and I'll just say, okay, let's say the instruction is now, okay, take the 30 that we had and 56 it. Whoa, I wrote, all right, now it looks like 305. So okay, so take the 30 and 56 it with 3. So now the computer says, okay, IP, you're gonna go to B now, so you're gonna go down here, and now the IP is at B instead of A, which I'll get rid of this too, so I don't confuse you. So IP is at B now, right? So now that IP is at B and A is done, we have 30 plus 3. So now we got 33, right? So we got 33 stored in here now. Looks like 35. Jeez. I promise I'll be better with this pad next time, guys. So now we got 33, right? So that's the next lesson I wanted to show you. I don't want to go too long as usual, but the idea here is that you can basically do everything by storing this information and with the processor. So the processor is made by Intel or Qualcomm or AMD or ARM and all these different manufacturers and types, right? And what these processors do is they have an instruction set, and these instructions correlate with these opcodes I was telling you about. So, for example, 56 might be add. A different instruction like who knows, like I don't know, 85 might be go to, right? So now if we get to C, if IP gets to C and we have go to in here and we say go to F, right? Which is going to be, let's say, code 85. Now it's going to skip D and E and the IP will now be F. Okay. Now this is a simplified version, slightly simplified version of how the processor works, but this is very close to the real deal. And this is the same logic and everything that it's using. So in other words, I'm not teaching you assembly language in this video because I don't want to teach the syntax of all that, but this is what's going on at the processor level and at the memory level. And it's very important to understand this because now it opens up your eyes to why memory is so important and really what the CPU and memory and the computer is actually doing. All it's doing is it has an instruction set, and inside of the processor is hard-coded instructions on how to add and subtract and move things around and go to and all that kind of stuff. Like that's like at the electrical engineering level. And then what happens is that it just follows these instructions and it just executes all these different commands. And there's not a ton of them. Like it's not like C++, there's no templates and like, all there's not most of the language features that we have, they just exist for humans. They don't actually exist for the processor. The processor doesn't need to know like what classes are and what like objects are and like high order functions and all that stuff. It doesn't need to know all that. It just executes these simple basic instructions and it gets stuff done. So tune in next time and we will go we'll continue on with this lesson. All right, thank you.